Hey guys, and welcome to Deep Learning Part 5, Recurrent Neural Networks in Python. Like the course I just released on hidden Markov models, recurrent neural networks are all about learning sequences. But whereas Markov models are limited by the Markov assumption, recurrent neural networks are not. And as a result, they are more expressive and more powerful than anything we've seen on tasks that we haven't made progress on in decades. So what's going to be in this course, and how will it build on the previous neural network courses and hidden Markov models? In the first section of the course, we are going to add time to our neural networks. I'll introduce you to the simple recurrent unit, also known as the Elman unit. We are going to revisit the XOR problem, but we're going to extend it so that it becomes the parity problem. You'll see that regular feed-forward neural networks will have trouble solving this problem, but recurrent networks will work because the key is to treat the input as a sequence. In the next section of the course, we are going to revisit one of the most popular applications of recurrent neural networks, language modeling. You saw when we studied Markov models that we could do things like generate poetry and it didn't look too bad. We could even discriminate between two different poets just from the sequence of parts of speech tags that they used. In this course, we are going to extend our language model so that it no longer makes the Markov assumption. Another popular application of neural networks for language is word vectors or word embeddings. The most common technique for this is called word2vec, but I'll show you how recurrent neural networks can also be used for creating word vectors. In the section after, we'll look at the very popular LSTM, or long short-term memory unit, and the more modern and efficient GRU, or gated recurrent unit, which has been proven to yield comparable performance. We'll apply these to some more practical problems, such as learning a language model from Wikipedia data and visualizing the word embeddings we get as a result. I want to leave you guys with one tip for getting through this course. Understand the mechanics first, worry about the meaning later. When we talk about LSTMs, we're going to discuss its ability to remember and forget things. Keep in mind these are just convenient names by way of analogy. We're not actually building something that's remembering or forgetting. They are just mathematical formulas. So worry about the math and let the meaning come naturally to you. What you especially don't want to do is the opposite. Try to understand the meaning without understanding the mechanics. When you do that, the result is usually a sensationalist media article or a pop science book. This course is the opposite of that. We want to understand on a technical level what's happening. Explaining things in layman terms or thinking of real-life analogies is icing on the cake only if you understand the technicalities. I'll see you in the next lecture.